This. Let me stop the share. I can turn my camera on, maybe. You can see my smiling face. There we go. We'll see if we'll give Arturo just a minute or two more to show up. Spotlight me. There we go. Lucky you guys. Hang on a second, guys. Sorry about that. Getting my dinner plans straightened out for the evening. I'm sure Crystal's already eating hers right now. What are you eating, macaroni and cheese tonight?
No, I had fish.
Fish, there you go. Good fish. And there you go, the phone starts ringing. Hang on a second. Actually, I gotta mute the other thing anyway. Hang on. Sure, it's some political poll asking me what I think about something. But, all right, well, we're going to talk about something here. So I've got some fun stuff. We're going to continue on in the diesel with. Let's share with you. Oh, probably should have gone to the top of this. It's a long one. It's going to be a long-winded night tonight, guys. Got 2 long PowerPoints to share with you. But that's okay. Okay, so we're going to talk about low-pressure fuel systems and high-pressure fuel systems. But then the high-pressure fuel systems kind of get broken into 2 areas that we care about. I mean, we could take rabbit trails for 2 weeks on fuel systems. But we really, in this course, because it is a Ford course, we are going to narrow it down to what Ford has to talk about. So we're really not going to talk in the low pressure systems. We're going to talk a little bit about some of the early low pressure fuel systems and pumps and stuff like that, just so you're familiar with them, but we won't get real heavy into that. But our real focus is going to try to keep to what's modern. When I say modern, I'm going back to like 1993. That would be considered modern in my book. But that would be most of our HUE systems and our common rail systems. And so we're going to talk about the low pressure systems that involved in that. We're going to talk about high pressure systems today and we're going to talk about them in a generic sense. And the reason we're going to do that is just so that you guys get an understanding of how the high pressure systems work, because it doesn't matter whether we're using a common rail, a distributor pump, a HUE system. The nozzle on a diesel injector, for all intents and purposes, is exactly the same for all of those kind of vehicles or all those kind of fuel systems. So I want to just kind of explain to you a little bit how that operates, how that works, so that then it makes it simpler when we get into the others. And then later this week, we'll cover the HUE system. And I'm sure you guys have looked in the canvas, and I'm sure, Crystal, you went, what in the world? Look how long this thing is. That whole thing on the HUE system is gigantic. I mean, and you know what? I didn't even put there's probably a quarter more than that, which I could put out there, if you went into some of the other, caterpillars and stuff like that. There's so much to know about that HUE system. It's so involved and complicated. Yet at the same time, it's kind of simple, but there's a lot involved with it. So there's a lot of reading in there. I don't expect you guys to necessarily have to do all that reading. I think everything you're going to need to know, I'm going to yap at you about. So it should be okay. And then next week we'll start in on the common rail fuel system, which is is a really interesting way they do fuel, and it's a lot simpler and a lot shorter in the Canvas. So next week will be a lot easier than this week, but this week's a little tough. And I did promise you only one test per week, but I lied to you because I do have a short test in there for low pressure, high pressure, and the Huey system, but they're only 10 questions a piece and they're pretty short. But my goal is that you get to know this stuff. So there shouldn't be a lot of pressure on you guys, but anyway. So what is the low pressure fuel system? The low pressure fuel systems is everything that's going to come from transferring the fuel from the fuel tank, delivering it to the high pressure system. So we've got two different fuel systems in a vehicle. And so what we're going to talk about now is what's involved in the low pressure fuel system. What are the pieces? Why are they important? What are we trying to do with it? And then going to try to talk you through a few diagnostic procedures that you'll need to know to get through it. It's just a summary of it. This is just kind of a picture of what a basic fuel system is. Usually going to have some sort of a low pressure pump. It's either going to be in the tank, right outside the tank. It could be a mechanical pump. Somehow it's going to be some sort of a fuel pump that's going to draw the fuel from the tank through a primary filter, usually a secondary, but not always. Different systems have different things. And then it's going to deliver fuel to the high pressure pump, which is then it'll raise the pressure up to, anywhere from 3,000 to 29,000 PSI, and then deliver it to the injectors. Okay. Let's see. So the second paragraph, that the operating and servicing of the low pressure fuel system is critical to starting the engine. It's for its power. If we have problems with it, we can lose power. We can have engine surges. We can have engines failing. I mean, with problems, the low pressure fuel system, we can have the engines fail and, eat pistons up and all kinds of problems like that from a variety of sources, whether we're diluting the oil to starving the engine for fuel. The Huey injectors will actually try to stroke themselves so far that they're trying to get the fuel in that they'll actually beat themselves to death. And I've actually seen them break the tops off them because they're working so hard, because the computer's just, all it's trying to do is get you the fuel out there in the cylinders to do what you're asking it to do. So it's going to do everything it can to do that. And they'll actually beat themselves to death. So there is a critical part of the system to make sure everything works the way it's supposed to. The pressure system, the functions of it, it's for storing the fuel. It's storing it in a way so that it doesn't evaporate away and that it doesn't contaminate with algae and stuff like that. And so we want to keep it a good, clean supply of fuel. It's responsible for making sure we have an adequate volume of fuel and an adequate pressure to the high pressure pump. We're trying to use the low pressure systems. We're going to use it to get rid of water contamination, other contaminations like dirt and stuff like that get in the fuel, prevent waxing and gelling, regulate the temperature. We'll kind of talk more in depth about it probably 3 or 4 times during all this, but high fuel temperatures, if the fuel temperature gets higher, the warmer that fuel gets, the thinner it gets. It's kind of like any kind of liquid, that the warmer it gets, the less dense it becomes. And remember that diesel fuel gets its power and its heat energy from its denseness. If it's more dense, it has more waxes and more heat capable of creating more combustion inside that cylinder. If we have a thinner fuel, it becomes less dense and it robs the engine of power. And we'll talk about a little bit more further. There's actually, they give you a percentage of how much power is lost for every 10 degrees. It's interesting. But we actually have temperature sensors on everything on there, try to monitor it so we can compensate for it. but we want to make sure that the engines, that the temperature is not overheated, but at the same time, we want to make sure that it's not too cold, because if the fuel's cold and we're in cold weather and stuff, it will, you'll get to that cloud point that we talked about last week, and then you can get to that pour point where the engine won't run at all. So we want to make sure that everything that the fuel coming to that engine is proper, and all that's going to happen through fuel conditioning in all of this. Okay. Some of the components that are involved in the low pressure system is going to be your tanks, all the fuel lines, the sending units, whether the sending units are a separate unit from the pickup, or they could be part of a high pressure pump, or a low pressure pump in the tank that's part of the pickup. Kind of a variety of configurations like that, depending on the vehicle. I think as far as Ford is concerned, our Transit has a pump in the tank. The rest of ours are all on the fuel rail. We have fuel filters, fuel heaters, water filtration, fuel coolers, fuel transfer pumps. Okay, so fuel tanks, obviously its most important function is that it stores the fuel. But the rest of it is so that it actually it's designed so that it can take in return fuel from the engine. That return fuel from the engine is going to do a couple of different things. If it's super hot, it's going to hit that fuel back there and it's helped cool that fuel. But if at the same time, if it's super cold and that fuel in the tank is cold, we will return hot fuel from the engine back there and try to warm up the fuel in the tank. So we're either, depending on what's going on, we're either going to warm it or cool it, but we're going to use that return fuel to do that. A lot of engines today don't use a whole lot of return fuel going back to the tank, because what they've discovered is that if we're using a pump to pump a lot of fuel up to the engine and then we're not using it, we're sending it back to the fuel tank, well, that's parasitic loss. That's energy that we're using to pump fuel that doesn't need to be there. So if they're trying to find and get every little thing to try to bring fuel economy and emissions down, then we want them, they're not sending very much fuel back to the tank anymore at all. Okay. Again, it's talking about cooling the fuel. If fuel losses in viscosity, not only do we have a problem with its denseness in the power problem at all, but it also becomes thin and it starts to lose its lubrication value. So we got to be careful that our fuel doesn't get so hot that it's so thin that we're wearing out parts. So we got to be, we have a lot of parameters that we got to keep that fuel temperatures in line with. Okay, here it is. A 2% power loss occurs for every 10 degrees of fuel temperature above 115 degrees. Okay, so if that went to 145, you'd have a 6% loss in power available in that fuel. Now, the electronically controlled systems have the ability to monitor that temperature. We know exactly what the temperature is going into the engine. So it knows that, okay, that if it's the fuel pressure going or temperature going in, there's 145 degrees, and it knows, it has an algorithm that it can figure out how to get that fuel, make compensations so that you won't notice that power loss. But the big thing is remember we talked about last week that fuel, the volatility of diesel fuel is fairly stable. It doesn't evaporate. Remember, gasoline evaporates at minus 40 degrees. It turns to a vapor that cold. Diesel don't do it till 100 to 140 degrees. Really, it really doesn't start vaporizing until 140 degrees. That's kind of the lower end of it. So we start putting that temperature, that fuel up and above that, and we start sending that back to the tank, and we start having a really hot fuel in there. Well, we're going to start vaporizing fuel. Now we're going to start having problems, because now we're putting vapors in the air, and that is a problem. So they do things to make sure that doesn't happen. And that's part of this whole fuel tank vapor ventilation stuff. Fuel tanks, in a gas engine, if you guys are familiar with any of that, we have to seal the system and send it through a carbon canister because of those vapors. But we don't have vapor problems with the diesel because we keep those the temperatures down. So the tanks on a diesel engine are just vented to atmosphere. If we sealed that tank solid, think about this. We'd start pulling fuel out of it. What happens if you take a straw in a balloon and it's blown up and you start sucking the air out of it? It's just going to collapse on itself. Okay. And what happens and we'll talk, I don't know if we'll talk about it later or not. So I'll talk about it now. If one of the problems you can run into, if the, spiders or something got up on the top of the tank and it plugged up the little vent on the top of the tank and the gas cap's dirty, or the guy puts the wrong kind of gas cap on or something like that, and now this tank is sealed, you're driving down the road and you're using fuel out of that tank, and pretty soon the guy says, man, I drive in this thing and pulling a load, and all of a sudden the thing just bogs down and dies, turns off. The truck stops, I cycle the key and start it up again, and it runs for a while and it goes. Well, what happens is that tank draws itself into a vacuum. You can't pull any more fuel out of it. As soon as the car stalls, the return fuel will vent to atmosphere and boom, fill up the tank with air again. The guy starts it up and he goes down the road again. So it's a very real thing that doesn't happen very often, but it is something that can happen. So we want to make sure as we're, maintaining things that are, we're looking for problems, that all these things are, you need to have an understanding that tank is vented to atmosphere. And the easy way to diagnose that is to take the gas cap off and drive it. If the problem goes away with the gas cap off, well, then you can go and search for a problem somewhere. In the venting system, whether it's the gas cap or the vent on top of the tank. I think we just talked about that. Okay, the vent that's on the top of the tank is typically a rollover valve, and it's a valve that has a little check ball in it. So if the truck was to roll over upside down, a ball would float to the top. It would float one direction or the other, I don't know. And it stops fuel from being able to run out that tank and run on the ground. Okay. So that's an important part of those rollover valves and those vents on top. And that's why those vents can get stuck. They're open to atmosphere up there. And so spiders like to crawl inside them. When spiders get inside them, they build these hard little spider webs inside there and plug that kind of stuff up. It happens a lot on gas engines. And here's just a typical picture of a fuel cap that's going to have two little rubber check balls with springs in them, and one's going to allow pressure. If pressure builds up in the tank, it can push out the top here and vent, or it will allow, if there's vacuum, it keeps it from creating a vacuum inside the tank. So you've usually got two systems, the gas cap and the vent on the top, kind of prevent all that from happening. But if you're in like an F650 or something like that, some of those big steel tanks, they don't have vents, man. Those tanks are just nothing more than a steel or big brass cap that screws on the end of a pipe. And so they're relying heavily on the vent that's on the top of that tank. And I think I've talked ad nauseum about ventilation. Tanks are designed to have an air pocket inside them so that as the fuel warms, you have the ability for everything to expand and contract and do all of that. Fuel lines are nothing more than either they're going to be steel, they can be braided lines, they're going to be nylon lines or something. Most of the lines on now are usually steel lines running the length of the body with a nylon pressed on the end of them and run up, and they're formed lines that run into the filters and the return lines. Important thing is they're not run through any part of the passenger compartments for safety reasons, obviously. They're pretty simple. Be familiar. You start working on any kind of Ford product or anybody's product right now. There's lots of the ends of the fuel lines are usually got some sort of a quick disconnect. Some of them are quick disconnects. Some of them are like, how in the world do I get this apart? Quick disconnects. So you need to be very careful with them, because a lot of times if you break that end on that fuel line, you have to replace the entire fuel line. So it's really to your advantage to make sure that you consult the workshop manual and say, how do I get this particular fuel line apart so that you're not breaking anything? And trust me, in a 20 6.7 at the secondary fuel filter, there's 4 different kinds of connectors on it. And it's like, are you kidding me? You know, and you got to figure out how each one of them comes apart. And some of them are very difficult. Okay. Fuel tank pickups and sending units. What's typical in a Ford and across the board, I think I've got a picture of one here. This is really typical. They're going to, the pickup, whether this is in Ford, this is kind of like what you'd see inside of a Transit, but our sending units would be very similar to this, except they wouldn't have a electric pump on it. It would just be a sending unit on a big apparatus like this. And it comes down, and this is usually some kind of a spring-loaded deal. And it's got these little nibs on the bottom of it. And this presses to the bottom of the fuel tank. And the reason for this is that what it does is, what happens in a diesel is, remember that diesel fuel is hygroscopic. Okay, that means that it attracts water. Okay, and when it attracts water, it attracts algae. Algae grows in there, and all kinds of other crud grows inside of diesel fuel. It can become gross. And if we just put diesel in the tank, and any water gets in there and starts growing, crud can start growing on the bottom of the fuel tank. And because if there's rust picked up from the tank, when it pumped in, or anything that got in there is going to sit on the bottom of the tank. If we leave that sitting at the bottom of the tank, it's just going to continue to grow and develop, and water would sit on the bottom and have all kinds of stuff. And then you really have potential that you have all this crud floating around the bottom of the tank, and then the guy turns a corner, sucks it all up in one big giant slug, and it goes through, plugs up the filter, does something terrible like that. So what they do with these diesels is, we have this sending unit sits at the bottom with these little nibs on the bottom. It sits on the bottom of the tank, and those create a Venturi effect all the way around it. And what it does is it acts like a vacuum, and it vacuums the bottom of the tank continually, so that nothing can stay on the bottom of the tank. If it's a big chunk, it can't get through the nibs, and that's okay. And the inside of this, there's going to be a nylon screen that's got some stuff that's going to prevent big chunks from getting in. But it's going to take all the little stuff. It's going to take all the water, all the other stuff. It's going to suck it up and take it to the primary filter. Okay. Because it can take it and handle it a little bit at a time and deal with it. What we don't want it to do is to build up and have a swamp sitting, because if you went back to like some of the early diesels in 1983, all they had was a tube sticking in the bottom of the tank, probably sitting around an inch from the bottom. So you had this swamp sitting on the bottom of that tank all the time. And like I said, you turn a corner, you could suck that garbage up. And so they really were trying to keep the tanks clean doing this. Now, one of the other things that they do, and you can't see it in this, but it looks exactly like this. Actually, you see it, that's what it is. This pickup bypass valve, that's what they got in here, the circle. It looks like it's part of the float. But this pickup bypass valve, this little circle right here, that is it's a little diaphragm that sits in there. And what happens is, if you're in a cold climate, remember what happens with diesel fuel gets cold, if it gets to the cloud point and then it barely wants to flow, and it gets to the pour point and it will not flow. Okay. So if that diesel fuel gels, it's going to start at the bottom and move its way up to the top of the tank. So you get in a cold truck or something, and the bottom of the tank could be frozen or gelled or whatever. So what it does is it picks fuel up about a quarter of a tank. Okay. So if you had only had a quarter of a tank, or you had an eighth of a tank, then it would be screwed, because it would just suck air and then you wouldn't work. But if the fuel's above that, and if the fuel's sitting up here and this is gelled down here, it's going to actually suck fuel in through this bypass valve to keep the engine running. And then as the return fuel comes back, it'll warm it up and eventually start working. So, and that is a point of service. If we have a problem, the symptom could be, hey, every time I get to a quarter of a tank, either the truck runs rough, or it doesn't run at all. And that's if this diaphragm in here on this bypass valve goes bad and starts sucking air, or you know, when the fuel tank's below that, or either suck air or just suck air totally, then the only thing you can do is replace this entire sending unit. But it is a point of a problem that we do see from time to time. Let me go up here and make sure that we aren't missing anything that I think that's probably good on that. Okay, so we talked about, I've alluded to fuel return system. So part of the low pressure fuel system's job is not only to deliver the fuel to the pump, but also to bring it back. And it's going to bring it back, and we'll talk about fuel conditioning modules in a minute here, but it either is going to bring it all the way back and drop it in the fuel tank, or it's going to bring it back into the fuel pump setup and recirculate it to heat the fuel and bring it back up. So it is responsible for bringing the return circuits back to the tank or into the inlet side of the pumps. I don't think there's anything greater on that. All right, so let's talk about fuel filters. And fuel filters are going to be the place that you guys are going to probably have the most, you know, as you become technicians, they're going to be the place that I think it says where you're going to intersect most, where your problems are going to be, where you're going to do most of your service work are going to be related around fuel filters. Because the fuel filters are there to filter out the problems, you know, filter out the dirt, filter out water. And if we maintain those, if they're not maintained, they may be a source of a no start or a hard start or loss of power or something like that. They're very straightforward. They're going to either be, you know, some sort of a fiberglass or paper filter that's just designed with a certain micron level to remove contaminants from the fuel. You're going to have, this is just a really good picture of a nozzle. This is an injector nozzle, and this is where the fuel sprays into the cylinder. And this is the pintle right here that's going to move up and down. And these are very, very, very tight tolerance. Fuel comes down, see this purple line right here? As pressurized fuel comes in here, it lifts this off its seat against the spring pressure and sprays fuel in here. But this is all lubricated in fuel and very, very tight tolerances. So if we get a bunch of dirt in here, it works to wear that out. Okay. And when that starts to wear that out, that's when you start getting leaky injectors and ones that don't work well and all kinds of problems. So it's really important that we clean the fuel. So where does the fuel contaminants come from that are in your diesel fuel? They're going to come from, they can come depending on where you're at. Most of the pumps in California are going to be really good fuel coming out of the pump, and it's going to be filtered. So we don't honestly see a lot of problems with that. But there's always the idiot who has the $80,000 truck that he just bought, and he's really low on fuel, and he had a tank, you know, sitting, you know, big, you know, 5-gallon can for his tractor sitting over there, and that fuel is just going to waste. And so, you know, I'm not gonna waste that fuel. That's what, $4 a gallon. That's $20. So he goes and dumps that 5-gallon can, you know, that's been sitting around for 6 months in his, you know, in his workshop. He goes and dumps that in his $80,000 vehicle. So now you've introduced a bunch of rust, a bunch of old fuel, and all kinds of junk into the car. Okay, so that's one really common way where we get a bunch of junk in there. You're also going to get junk in there just from the gas pump itself. I mean, depending on how dirty the situation is, or you know how dirty your truck is, you take that gas cap off. It just doesn't take a lot of dirt, just gets in there. You also have the vent. Remember, that vent is open to atmosphere on top. If you're in a, you know, I work on some work trucks that are just dirt balls, you know, and they're sucking dirt in. So you get there's all kinds of ways that dirt can get in there. Besides, you can get moisture in there. You know, so not all the water gets filtered out of that fuel that's coming out of the gas tank at the gas station. So there's water's emulsified in that fuel, and you may not see it in the fuel, but it's emulsified in there. And so you get all these contaminants inside there. And our job is the fuel filter's job is to make sure we take that out. like I said, most fuel system wear takes place between 5 and 7 microns. I think I have a picture here of this is kind of magnified, but the orange circle there would be the size of a human hair. Okay. 5 to 10 microns. There's a 5 micron, and then the one in the center is a 10 micron. And then we try to use our secondary filters to get them down to 2 microns. We're trying to get, so if you make that smaller into the size of a human hair, we're talking about some really, really, really small particles. But we want to get that stuff out of there because all that stuff is abrasive and hurts our fuel systems. So I think this is a test question. I think the answer to the question is 10 microns of fuel system damage. Most fuel system damage happens around 10 microns. I could be wrong on that. Hey, and do you guys know, Gavin, are you guys know that when you guys take those tests that are in this course, you could take them 100 times until you get them right? And they're the same questions every time. So if you didn't do well on a test, do it again and get all the right answers, okay? So, because I noticed one of you guys didn't do very well on a test, you need to redo it. So some of the things that happens, if you have fuel systems where we're going to end up with poor pressurization problems and atomizations, we're going to talk about what in the world is, what's so important about pressurization and atomization. We talked about it a little bit with fuels last week, but high pressure systems, we're going to talk about it today. But when we start having problems with that, we start having high fuel consumption problems, hard starting, they run rough, we lost the power, or the biggie, what you'll really start seeing is smoke out the tailpipe. And the other emissions, we don't typically see the emissions going out the tailpipe outside of smoke. And so we start seeing smoke out the tailpipe. It becomes an issue. This is some of the areas we talked about how junk gets in there. This asphaltenes, those are carbon crystals that are developed, and we can't stop them from getting into the fuel because those happen when these, especially happens on the common rail systems, when we're running these pressures up higher and we're taking them into the engine and we're kind of cooking that diesel fuel up there and sending it back. We're creating these little carbon crystals in the fuel. Okay. The other way that these asphaltenes get produced is in fuel, especially if it's stored and it's old and it sits around, it becomes you get this sticky, tarry feeling that you'll pull the fuel filter out of some old truck, and the filter's got a tacky feel to it, or sticky kind of feel. And it's very difficult to identify that. Is it algae in the tank, or is it this asphaltene stuff? And it plugs filters. It plugs them really bad, and it's really abrasive to the fuel system. So just be aware of that. When you pull a fuel filter down, it's like, okay, what do we got going on here? And if the fuel's old and it's a real problem, it may be best for the customer to have that fuel tank, thing pumped out of there and get that fuel tank cleaned out and put it back in so that we don't have these problems. I didn't switch this, did I? I wanted to show this slide after this slide. Water, not only, so now let's move from contaminants in the fuel, from like, debris and dirt and junk like that, to water. Okay, water's a biggie in diesel fuel. Remember, it's hygroscopic. It attracts water. It emulsifies in the water, and it just creates all kinds of problems. Algae likes to grow in it. If you get solid water running through the injector barrels and stuff like that, you end up with, it doesn't lubricate well. So you wear parts out, you can have all kinds of problems. Plus if it sits in the high pressure pumps and stuff like that, those things are made of steel, and that steel will rust, and you'll end up with rusty parts and all kinds of problems with it. So, and like I said, it combines with sulfur and the fuel, and it becomes an acid. And so we want to do our best to get the water out of the fuel. And we have some fuel conditioners. We're going to talk about that in a bit. Okay, so it's talking about iron rusts inside there, and the microorganisms grow inside there and plugs with fuel filters. Okay, so we have a couple different ways we handle water in the systems. We have our older systems just use water separators. Now we use what we call fuel conditioning modules, and we'll talk about that here in a second. But they're going to use special kind of fibers and stuff like that are going to try to filter the water and separate the water from the diesel fuel. So that's going to happen by a thing called coalescing. Okay. When we coalesce something, it means we're bringing something together. The water that's in the diesel fuel is typically emulsified into the diesel fuel. So it's a part of the diesel fuel. What we're trying to do is coalesce the water, bring it back together into water molecules, and bring it back as a solid in water, and the water will be heavier than the fuel, and it drops to the bottom of the separator. Okay, so we're trying to get it to separate out. Okay, and so we're going to do that through some kinds of filters. We're also going to do that through some centrifugal actions to try to bring that water back to water. So the coalescence can be achieved by spinning fuel in the fuel bowl, and it's separate to try to separate the emulsified fuel and bring that water back to water again. You can kind of see how it ultimately turns, as it spins through the water separator. It's going to come in here and it's going to turn into water particles and sit in the bottom. And once you get enough of water in there, it comes to the bottom, and then they're going to have couple of different ways that are going to tell you that, hey, you got water in the fuel. They have some that use a float. You're going to have a float inside there that's going to, lift up because something floats in the water and it turns the light on. Hey, you need to drain your water. Or most of the ones now are a water and fuel sensor that, two electrical terminals sitting down there, and it's just measuring conductivity across those terminals, which they can measure the difference between water and fuel and tell you that you got water in the fuel. It's going to turn on a light on the dash and say, hey, you got water in the fuel and you need to deal with it. Most of the modern ones we have today will not only turn on the light on, but they're going to derate the engine and do everything they can to shut you down so that you don't keep driving it. Because if you run water through your high pressure fuel system, it will destroy it. Okay, so waxes and paraffins that start to get cold and congeal when they're cold, those are the very things that we really like to have in the diesel fuel because they're really high in energy. Remember, they're thick, heavy pieces of energy that's inside that fuel. And when it's hot and warm and flowing, it's really good and works really well through the fuel. But when it's cold, it starts to congeal and form crystals and remember, it gets kind of gels and turns to that cloud point, and then finally turns to the pour point where it doesn't work anymore. So to prevent that from happening, we want to make sure that the fuel is gonna work at the temperatures that are outside. So if I think when they make, depending on part of the country and the time of year it is, they're going to make fuels that are going to, they usually can predict that, hey, it's going to be, 0 degrees in Montana for 2 months or something. And the fuels that they sell are going to have stuff in them to try to keep it from happening. So there's different blends of fuel that are going to do that, but we're also going to kind of treat it the way that with fuel heaters and stuff like that to try to keep that from happening. But they do have the dispersants or whatever they put in it. They do put stuff in the fuel to prevent that gelling from happening. Okay. The other thing they're going to do is they're going to put heaters in. This is actually a heater bowl out of a 7.3 liter diesel, and it's just this is a heating element that sits in there, and it just, when it gets to a certain temperature, this electricity goes through there and just heats the fuel. There's a couple of different kinds of fuel heaters that are out there, and just to heat the fuel up. Some engines, talking about trucks and stuff like that, will actually use heater hoses to go down back through and heat the fuel to keep the trucks on the road. Okay, so I think we'll talk about conditioners here in a second. Yeah. I think we've covered that enough at length. So they're going to use either heaters to keep it from happening, or they're going to chemically treat the fuel, keep that from happening. We talked about that at length. Okay, so Ford's going to use two different kinds of modules for their fuel. We use, and when I say that, from the 6 liter in 2003 forward, the 7.3 just used a regular pump on the fuel rail and just one filter up on top that had a heater in it. Pretty simple system. We use in the 6 liter and in the 6.4, we use what we called a horizontal fuel conditioning module. In other words, that module that laid on its side horizontally, and it pumped, filtered, conditioned the fuel. When I say it conditioned the fuel, what it's doing is it's pumping the fuel in. It is separating. It's got the centrifugal action that separates the water out of it. It does what it has to do to eliminate air in the system, to try to send a pure fuel that's coming through with no air in it, and it warms it. And it warms it by, as the fuel comes, it has a little thermostatic little device inside itself that as the fuel comes, the return fuel comes back in, if it's not a certain temperature, it's going to open a valve and it's going to just return that return fuel back into the inlet side of the pump and just kind of recirculate that high pressure, or that low pressure system. It's just going to keep recirculating it. If it's above a certain temperature, it's going to change that valving. It's going to send it back to the fuel tank itself. And I think I have a picture of that here. It's usually going to have a water and fuel sensor in it. It's going to have a fuel heater in there, and it's just one nice compact unit. The later models, like the 6.7, the 3 liter, and the 3.2, all have what we call just a regular fuel conditioning module, and it actually sits upright rather than on its side. Okay, so this is a picture of a horizontal fuel conditioning module, and this is what's in a 6.0 and a 6.4 liter. Okay, so the fuel is going to come from the fuel tank, and it's going to come in here. It's going to get circled around and get sucked into the pump, and then the pump is going to pump it around here, and it's come through the filter, then it goes through the pump, and it's going to do all its spinning and everything like that, and the water's going to fall to the bottom of this drain. It's going to send the engine fuel to the engine. It's going to come back from the engine. It's going to decide whether that fuel is warm enough or not. If it's not, it's going to send that fuel back to the inlet side of the dirty side of the pump or filter, and just going to go around like that. If it decides that the fuel is too hot and it needs to go back to the tank, it's just going to send it on back to the tank. So this has you take this big nut off here. There's a big giant primary filter inside of here. There's 3 bolts on here. A pump can come off the end here. And then inside this chamber here is there's a water and fuel sensor and a fuel pump plug. And then there's a heater inside here as well. So the same thing happens in the regular fuel conditioning module that's not a horizontal. Any fuel that's above 109 degrees just goes directly back to the tank. And think this picture shows the same kind of thing. It's going to come from the tank. It's going to go through a 10 micron filter. It's going to go through a pump, and then it's going to go to the engine. And you guys, there's my, I don't know, there we go. I'll move you guys' pictures out of my way here so I can see. And then it's going to go back to a 4 micron filter, and then can bleed right on back to the tank. And then your high pressure fuel is going to come back to over to the high pressure fuel, all filtered out. So, I think I've covered that at length. Yeah, this is, I alluded to this earlier. So the common rail fuel systems pressurize that fuel and create more heat. And so that fuel comes back to the tank. It can come back a lot hotter. So we end up with fuel that's above the flash point. Okay, so now you've got fuel that's turned into a vapor, and things become a little bit more unstable. And so we need to stabilize them. So we're going to use fuel coolers to do that. We did not use a fuel cooler in a 6.0 liter, but in the 6.4, because we remember when we went to, well, you wouldn't remember this. We'll talk about it later this week, that the 6.4 went to the first common rail system that we used. And so with the introduction of those higher pressure fuels, we introduce fuel coolers so that we can bring those temperatures of those fuels down so they don't hit those flash points and start vaporizing. Okay, and we keep the viscosity where we need to have it. And here's a picture of a fuel cooler on a 6.4. This is a kind of a top view of a 6.4 engine. And they screwed the picture up here because this is actually the oil filter and this is a secondary fuel filter, so a little backwards here. But this is a fuel cooler. And what's happening here is fuel comes into this engine through this, comes up into this secondary filter. There's one of those horizontal fuel conditioning modules down below on the frame rail. And the fuel comes up into this filter. And then this is a gigantic filter. And I believe it's a 4 micron filter. And then it comes out of here and goes, I'm sorry, I misspoke. It comes out of here and goes through a fuel line that comes around the backside here, and the high pressure pump sits underneath this turbocharger. And then, so it pumps the high pressure fuel up, and any return fuel that comes out of that it doesn't use comes up to this fuel cooler right here, leaves this fuel cooler right on this side here and goes right back into the inlet side of this. And then this fuel cooling system has its own little reservoir up here and its own little pump and its own little radiator. And it just, and it runs a very cool system. It's just to keep the temperatures of the fuels cool that run through that pump. So the filter media, we talked about that. It's either going to be paper, which is cellulose. It can be microglass, cotton, felt, wood, any kinds of absorbent materials that are going to not let the contaminants pass through its pores, and they're going to be designed to a certain micron level. This is an important thing for everybody to know, is that a lot of additives that they're going to sell you at Pep Boys and stuff like that, they're going to try to sell you alcohol-based additives. Okay, alcohol is going to do several things to our diesel engine. And the reason that they try to sell alcohol, and they try to sell it for gas engines and everything too, is that the water that we try to separate out, especially in gasoline will not mix with water at all, but the gasoline will mix with water, and alcohol will mix with gasoline. So we can emulsify the water in the water in the alcohol, and then we can emulsify the alcohol in the gasoline. Okay, so you end up with this stuff going through your car because they can blend them together like that. And they're going to do the same thing with the diesel. They're trying to put diesel in there. They say they're getting it in there to try to dry out the water out of the diesel fuel. But remember, we're trying to do with this, the water separators, to get the water out of the system, not try to blend it in. So we're going to, when you start putting alcohol in there, you're raising, well, not raising, you're slowing down. Remember, it burns slower than even gasoline. So it's going to cause a knock. It's going to cause all kinds of problems. You're going to lose power. The worst thing it does is the alcohol dries out all the rubber seals in the diesel fuel system, and it breaks down the filters. So it's critical when you're putting additives in a diesel that you're not putting anything with alcohol in them. Diesels don't like alcohol. Again, just pictures of filters with a microglass, which just filter out, they work as the fuel comes in, it spins it and it separates the water from the diesel fuel and tries to get the water to come back together again as a whole and drop to the bottom of the thing. And these filters will have drains on them. You open them up and drain the water out of them. I think, did I point that out back here? This here is a drain on these on the horizontal fuel conditioning modules. They have a little drain. You take this plug out and the water will run out of them. Our fuel conditioning modules, the ones that are horizontal, there's a drain on the bottom of those as well. So that's one maintenance point on them if you ever have to. If the fuels are good, you should never have to drain them. They should just be able to be fine. And so they're classified not only by what they're made of, but how efficient they are. And that's the most important part, is how efficient they are. Now, I think there's a slide on this later, but remember in your gas engine class that a engine oil filter, remember, has a bypass valve in there, so that if the oil filter becomes plugged up, what's it do? It comes off its seat, it lets oil pass. So that the theory is it's better to have dirty oil running through the motor than no oil. Well, that's not true of a fuel filter. Fuel filters, the more they become, dirty or plugged up, the more efficient they become. Okay. They just become better and better and better and better filters to where they won't let anything through. Okay. They're filtering everything. So they don't have any kind of a bypass design. So they will eventually stop passing anything through them. Like here's just a picture of a 5-micron filter. It'll let the little stuff through. And here's a really fine one that won't let anything but the pure fuel through, besides anything smaller than 2 microns. But as all this media gets plugged up, pretty soon it just becomes a better and better filter to where it can't filter anything more. It can't even flow fuel through it. This is important for you to know, is that a 10 micron filter is pretty typical for a primary filter, and they'll get down to 2 to 4 microns for a secondary filter. And this is if you have a system that's got 2 filters in it, you're going to have, this one here's an example of a very sloppy one, 150 microns to 15 microns. But it all depends on what the manufacturer has set out. But most of our new cars our new trucks that have are really high efficient common rail fuel systems. They're 10 to 15 microns down on the bottom on your primary, and as tight as 2 microns on your secondary. 2 to 10, 2 microns on your secondary. Important kind of to know that 2 filter systems will last longer than your single filter system. And it's obvious because we're taking, we have a big filter down below that's taking all the big chunks out. And so the secondary filter, it's only taking little stuff out. And so you've got, you've got double the efficiency. And so they usually last longer. And it's important and that's important for you to know in the fact that it's not uncommon for, especially some fleet customers. They'll say, I want you to change my fuel filters every time you do the oil filter. Well, and a lot of times they'll change their oil filters too often. That, if you change your fuel filter every, 5,000 miles with your oil and filter, well, sure, you're always going to have clean filters and everything, but you're doing nobody any favors between the cost to change the fuel filters could be up to $150, maybe even more. But also the cost of the environment. When you're taking a dirty old filter off and you cleaning it out and then chucking it in the trash, that's all that stuff has impact on the environment. And I am no environmentalist, but it doesn't make any sense to be throwing, good money and good stuff in the trash. Those fuel filters will go typically, I think, 30,000 miles. And in today's world, if you keep that fuel clean, you can go much further than that. Keeping in mind that even if that fuel filter gets dirtier and dirtier and dirtier, it's not going to start passing dirt through it. It is only going to become more restricted, and you might starve for power, but you're not going to ruin your fuel system for having a dirty filter. So, and we can test those filters. But if you just go to the regularly recommended maintenance on them of 30,000 or whatever it is by that manufacturer, you're usually very safe, and not over replacing filters or overselling stuff to a customer. There's plenty of money to be made without selling stuff that doesn't need to be there. This is an interesting point, is that spin-on filters, whether they're oil or fuel, they're exempt from hazardous waste restrictions if they've been drained properly. If they're what they call hot drained and crushed, if they're if they've been pulled off while they're hot and then poked in the bottom and crushed so that everything gets out of them. Okay, so you need to, and I don't know the ins and outs of this fully in all areas, but you just need to know wherever it is you're working to make sure that you are following all the regulations as to how to get rid of fuel and oil filters. So this is a continuation of that. Now, this is an important fact for you guys to know, that, and I don't know that it's a test question, but it's very important for you to know that this is a fuel bowl off of a 7.3, but you can see this guy's poking at this little thing with a screwdriver. And what he's poking at there is, this is a standpipe. The fuel filter it's just going to be an element that sits around here, and fuel is going to come in the outside of the bowl. It's going to filter from the outside of the filter into the center of the filter. And then it's going to go out this standpipe and go out some piping out to the bottom and into the engine. This filter that sits on here has a little nipple thing that points down in here, and it pushes on this area where this guy's poking. And what it does is it pushes a valve inside there to open this standpipe up. And what that does is that it prevents somebody from, I think my filter is plugged up, causing my problem. I'm going to pull the filter out and just put the cap back on and run it without a filter. It won't run. It has to have a filter in there with a thing in there pushing it down in order to make it run. The 6 liter is very similar. It has another kind of device in there that does the exact same thing. It's to prevent the engine from being run without a fuel filter, because we don't want to run an engine without a fuel filter. Anybody want to take a stab as to why we do not want to run a diesel engine without a fuel filter? Because we don't want a bunch of dirt going through it, right? Remember, we're dealing with really tight tolerances and stuff. Gavin, Arturo, are you guys awake out there?
Yeah, I'm here.
All right. Okay. Crystal looks like she's about to fall asleep. If you fall asleep and you bruise your forehead on your keyboard and it's my fault, I'm going to be mad at you.
Okay.
Okay. Okay. Okay. So let's talk about transfer pumps. Transfer pumps are nothing more than stuff to get the fuel from the tank up. They can be pumps that are going to be inside the fuel tank. Like I said, our Transit has that. The rest of ours are in some kind of a fuel conditioning module. Now, when we talk about transfer pumps, the term transfer pump is really kind of twofold. We're talking about transfer pumps that are going to deliver the fuel from the tank up to the high pressure pump. The 6 liter, the 6.7, the 3 liter, and the 3.2 liter all have electric pumps that are going to supply everything that it needs to the high pressure pump. No, that's not true. The 3.2 liter and the 6.4 both have low pressure pumps, but the other ones are going to be high pressure pumps that are going to deliver like 60 psi to the pump, to the high pressure system. The 3.2 in the Transit and the 6.4 engine have like a 5 to 8 psi pump, real low pressure, that's going to deliver to the high pressure pump. But the high pressure pump in itself is going to have another transfer pump that's mechanically driven. And I think we're going to talk about that here in a second. This is an example of a gear pump that's some kind of a mechanically driven gear pump that's pumping fuel. Ford doesn't use anything like that, but it is out there, and some of the older diesel stuff that it's just a mechanical type pump. They work really well. They use a hand primer pump. If we change a fuel filter and you get a bunch of air inside there, the engine will not run. So we have to bleed the air out of the system. So these gear pumps won't do that very efficiently at all. So they have a hand primer pump. A lot of old diesels had a hand primer pump that you would pump on the fuel system, and it would bypass the pump and fill the fuel filter with air and bleed the system out. Some older diesels were very difficult to try to get air out of the systems and get the engines to run again, because you have to get all the air out in order to get them to run. Most of our systems are with the electric pumps. We don't even have to worry about that. And in today's world, you probably won't have to worry about that at all. So I'm not going to bog us down with a whole bunch of this here. Again, this is an old type, old, like you'd find in an old gas engine. The old 6.9s and 7.3s had a diaphragm pump, and this just works off of a cam. This lever just goes back and forth like this, and it pulls down on a rod here, and it just runs a diaphragm in here, and it just sucks fuel in, pushes it out. It's a super old, simple system. A series of valves inside here just work to suck fuel out. It becomes higher volume at higher RPMs, but at low speed it doesn't. So they're kind of inefficient, but they were sufficient for old systems. We don't use those anymore, and we don't really have you won't even see them. However, piston type pumps you might see. With the introduction in 1993 with the first 7.3 engine, it had what we called a tandem fuel pump. And what it was it had a 2 piston pump. It might have been just one. It was 1 piston, but it had 2 valving systems on there. And it had one port of it would pull fuel from the tank and then push it through the filter. And then from the filter, it'd go back to another port on the same pump, and then it would pump that pressure up and send it out to the injectors at about 60 psi to be available for the HUE injection system. So that is a piston pump type system. And I think I've got a picture of it here, and it also did was run off the center of the engine. It was kind of turned more vertical, but it ran off an eccentric on the camshaft up on top, and this piston just moved up and down in here and just pumped the fuel. Super reliable pump. The only thing we ever had to change these for was they would leak. Something would go bad inside there and they would start to leak, but I never ever replaced one for not pumping fuel. I changed 100 of them for leaks, but I never changed one for not pumping fuel. But that you will see this on 1993, 4, 5, 6, and 97 up to, yeah. And then we didn't build a 98, and then 99 was a different electric pump. But so for 5 years, and these are still out there in plentiful form. So you have potential to be able to see that system in there. Its pressure is regulated by spring pressure against the piston. Nothing too exciting about that. But here's the biggie. We start getting into electric pumps. We have electric pumps in the tanks, we have electric pumps in the fuel conditioning modules, and we have electric pumps on the rails. And they're going to be really just a pump that's just a rotor that sits in a stator here, and it's just going to drive a pumping chamber. Fuel is going to run through it and run all across all the electrical parts of this pump. And so it's all going to be bathed in fuel, and it won't blow up because fuel won't ignite. Only vapors will. And remember that diesel fuel is exceedingly stable, so we don't have any problem with that at all. But a gasoline does the same thing. We're going to run gasoline straight over that fuel pump and inside of a fuel tank and everything, and it will not blow up because we don't have vapors to blow it up. But how this operates is, we're going to cycle the key on. As soon as electricity is going to the pump, it's going to pump fuel. We can vary that, depending on the vehicle. Some of them just are on or they're off, or we might modulate it. We can change that through the computer and make the pump, run faster or slower so that it's only delivering the fuel that we want it to. And it all depends on the vehicle that's out there. But we're going to have either going to be a vane type or a roller type. And this roller type it's just going to, as this thing spins around here, it's going to suck fuel in, and these rollers are just going to push the fuel out, and it's going to discharge it out the side, and it's just going to run as it spins. So, really reliable and really simple. Then they're going to have a vane type pump. So it's going to be the same thing. I don't have a picture of it. The same thing, only it's going to have, instead of rollers in here, it's just going to be vanes that do the same thing. Okay. And these are just electric pumps that are just delivering fuel to the high pressure systems. Now, I think that's probably all you need to know about that. They're I think I'm going to talk about it when we get into the common rail system. We talk about the pumps, but I'm going to just bring this to your attention at this point. The 3.2 in the Transit and the 6.4 engine that we built from 2008 to 2010, they have their high pressure fuel pump has a transfer pump inside itself. So we're going to not only transfer fuel from the tank with an electric pump, we're going to bring that into a transfer pump. That transfer pump is then going to deliver fuel it's an unpublished number, but it's usually around 60 PSI to that high pressure pump at an operating pressure that it can then use to pump use to make the high pressure fuel. So when we talk about a transfer pump, those are called transfer pumps that are onside those pumps, and they're not serviceable, but they're just part of the pump and they're mechanically driven. And I think I've got those are going to be you're really going to cover those at length in the high pressure pumps in the common rail system next week. So I just want to bring that kind of thing to your attention. So maintenance of the low pressure system, obviously the problems that we can have are going to cause starting problems, rough runnings. You get either going to be from, most of your problems are going to be dirt related, crud in the fuel. But keep in mind that other things that can happen in that low pressure system, because remember, the low pressure system is everything that's in that tank coming up. If somebody fills that low pressure tank with gasoline instead of diesel, that is a problem too. So, or if the idiot puts DEF in the diesel instead of in the DEF tank. And do you guys know what DEF is when I say DEF? Diesel exhaust fluid. It's the fluid. We'll talk about that in a few weeks, but it's kind of a water stuff, and that will be a disaster for the fuel system. So we need to make sure that those things, as far as maintenance concerned, there's not a lot of maintenance involved with it outside of changing the fuel filters. But if we're going to be checking these things, and we're going to go through some obvious checks that we're going to do here, fuel volume is one of the things we're going to measure, is make sure that we got enough volume, to supply the high pressure system. The manufacturers are going to say, hey, that this thing's supposed to put out, so many cc's or so many quarts of fuel over a certain amount of time. And that's a specification, whether it's a quart in a minute or a pint in 30 seconds or whatever it is. It needs to be able to deliver that. If it can't deliver that, then you have a problem, and it needs to be able to maintain that. So the other thing that we can have in a low pressure system is air. If we're sucking air someplace, if depending on how this thing's configured, if an O-ring went bad or a line cracked or something like that, and this thing's on the suction side and it starts sucking air through the system, that air bubbles can cause all kinds of havoc. Remember, we can't compress air, so the engine's not going to run right. It could either not run at all, or it could run rough, it could hard start, and all kinds of things. Don't see a lot of problems with that in the new modern engines, but it can happen, and just be aware that it can. And some of the easiest ways to diagnose that, they're using a kind of a glass thing here. But we usually go to the hardware store and you can buy clear plastic line, and you just rig that up between the fuel lines, and you can watch the fuel as it runs through, and you can see if air's coming through there. Now, the first time you do that, you're going to say, well, gosh, this system's a piece of junk. Look at all the air coming through there. Because it comes through there, you get a level of foam coming through there. You can't stop it. But you'll learn through experience, well, what is okay and what is not. I mean, there's big air bubbles or just lots of nothing, just air coming through is obviously a problem. But some foamy air bubbles coming through there is usually tolerable, and we don't want to have a heart attack over it. I would expect what you're seeing here on this picture here, I would expect that to be normal. More talking about the air in the system. Okay, we're going to cover some of what we want to find. Like I said before, filters become more efficient the more dirt that's in them. So they just kind of you'll be able to tell a plug filter because you'll have a pressure loss, or you'll have a suction. You'll create a vacuum on the high pressure pumps. So, and again, when we talked about over servicing filters, we don't want to do that. Now they're saying we want to check for restrictions and not have more than 12 inches of mercury vacuum on the filter. I would suggest that you probably don't want to have 12 inches. I would want to keep that. That would probably be on the maximum. I wouldn't want to see above 10, but it would really depend on the manufacturer. Kink lines in the fuel lines, restricted fuel pickups, and I'll tell you about fuel restricted pickups here in a second. That can be a real issue and a reality. So this is a picture of a fuel system, very basic schematic of a fuel system. You have a tank, go into a primary filter, to a transfer pump, to a secondary filter, maybe to a cooler, to the high pressure pump, whatever, maybe back to a cooler, and then back to the fuel tank. Okay. Very common system. Okay. In our 7.3 liter engines, in that fuel pickup, remember that pickup that had the little nibs on the bottom of it? There is two filters that are inside that pickup, and they don't tell it. It's not published. Nobody tells you there's filters in there, but there's these filters inside there, and they'll plug up, and because of algae or those asphaltenes or whatever, however you pronounce that, asphaltenes, they'll plug up inside there, and then all of a sudden you can't get fuel out of this pump. Now there's no on that particular one, there's no primary filter, but there's just a pump coming from the tank. And you can't get, we have a low pressure problem. We have, it's something that the truck won't go over 30 miles an hour, or won't pull a hill or something like that. So we drop a vacuum gauge on between the fuel line, between the pump and the tank, and we watch that vacuum gauge. Technically, this thing should be completely free flowing and we should have no vacuum there. But if we have a restriction here and we're trying to suck here, what's going to happen? What will happen if we have a restriction here and we start pulling here? What's going to happen on this line? Somebody tell me. Come on, Arturo. What happens when you suck on a straw and put your finger on the other end of it? What happens?
It stays, it doesn't drop.
Yeah, because you created a vacuum inside the straw, right?
Yeah.
Okay, and that's what we're measuring here. We're measuring a vacuum on here to say, hey, do I have a restriction? If I'm creating a vacuum here, then I have a restriction here. The same way, whether it's in the tank or if you have a primary filter before the pump, if we check it here and we draw a vacuum on here, and what they say, the maximum of 12 inches. Okay, that's a lot, but if we're drawing a huge vacuum, you're going to have some restriction. But if you have beyond the manufacturer spec, that this filter is plugged up. Okay, so we can tell that this filter is plugged based on the restriction that it's placing on this fuel system. Okay, we can also test this system by using pressure. We can test the pressure here. And typically you're going to check the pressure where it's the easiest. And then if you have a problem, you kind of go backwards. But if we have low pressure coming out of the pump, well, we could have a bad pump or we could have a restricted filter. Okay. So if we have low pressure here, then we need to go find out why. We need to find out, if we have a pump that's not pumping, enough pressure, and we have a high vacuum on this side here, then we have a pretty good chance that we got a plug filter. But if we've got no restriction on this side here and a pump that's not pumping, then we know, hey, we probably have a pump that's junk. Okay. So just some different testing points that we can test. The other thing we can do is we can check volume here outside the secondary filter. We can take a volume test to find out, hey, is this thing capable of delivering the volume that we need? We can check pressure at different points in the high pressure system, and we can check volume on the way out. So there's lots of different areas that we can check in this system to try to determine, do I have a pump, a bad secondary filter, primary filter. Typically in a Ford, if you're going to have any kind of filter problems, you're going to change them both. They come both in a box, and so you're just going to change them both out. But if you really want to find out what's going on or a problem with the car, you can start checking these things out. Typically what we're going to do is, did I drop that in there? I might not have. I made a video. I may not put it in there. I'll drop a video in on the canvas that I took of measuring a fuel pressure on a 6-liter. And what we do is we're measuring the fuel filter, or measuring the fuel pressure out past the secondary system. And we're checking it and seeing if this whole thing is capable of delivering what we want it to do. And it gives us, I think it was giving us like 50 PSI, which is exactly what we're looking for. Okay. So if you go there and find out everything's good, then you're golden. But if you go there and it's not good, well, then you got to go find out why. You can't just start hooking parts at it and say, hey, how, what part's going to fix it? You need to go find out, start putting vacuum gauges and try to figure out where the problem is. Then you can repair it right the first time. Like I said earlier, when cartridge filters are replaced, you're going to need to, things are going to have air in them. On the 7.3 and the 6-liter, it is no big deal. You just cycle key on and go. If you are working on a 6.4 and you change the filters and you don't bleed it properly, that truck won't run for hours. you have to use a proper bleeding procedure to make sure that it's done. And the procedure for that is, if you change the filters on a 6.4, all you have to do is cycle the key to on for 30 seconds, probably 10 times, and it usually will bleed itself out fine. If you start it and then it stalls, then you put air in the high pressure pump, then you have a problem. Then you have to get tools out and actually bleed the air out of the system and try to get the thing to run. It's very difficult. The 6.7, if you don't cycle the key properly, it will stall, but it will quickly start again. So it's not a problem because it's got a high pressure. It runs like 60 plus PSI in that low pressure system. So it flushes itself out pretty good. But the 6.4 only runs about 4 PSI in its low pressure system. And it's a real booger to get running again. And so you just got to know what you're working on and what it takes to get them to run. This is just what I just told you about testing all those low pressure systems and high pressure systems, just putting pressure gauges on, just redundant within the. We covered all of that already. Yeah, same thing. So that's all good. Okay, so this is kind of an important thing. Just keeping air out of the systems, especially if we're putting new injectors in vehicles, is these injectors are really high quality, high tolerance pieces of machinery that are really precise. And they're designed to run in fuel, and the fuel cushions them and acts as a lubricant and does everything. But if we're pushing air through these things, and that you end up with, steel impact against steel, and it shortens the life of an injector. So it's important that we bleed these things properly, so we're not pumping a bunch of air through these things. We've already covered all that. We don't care about diaphragm pump problems. Trust me. We talked about the vent problems with when we talked about the tanks earlier. Suction line problems. Okay, so this can become a very real thing. Oil contamination of the fuel. In other words, we're getting oil in the fuel. You say, how in the world can that happen? Well, it can happen in the HUE systems, because the oil, a high pressure oil that runs the injector sits right next to the fuel in the oil rails. And what happens is those O-rings can go bad, and then engine oil pressure, the fuel that's coming into that thing is only 60 PSI, and engine oil pressure can exceed that. Okay. And so oil can run into the fuel and start burning. And so what happens is we have a high oil consumption issue with an engine, and we have oil consumption, and we also could turn our fuel black, because as the oil circulates through there and the fuel circulates back to the tank, now all of a sudden you're getting this black stuff in the fuel. You'll open up the fuel cap and it's like, well, man, what in the world's in this fuel? It's because we're putting oil in the fuel. Not a huge problem out there, but it is something that can be an issue. And how to find that is we usually you could take a paper towel and take some fuel on there. And when you do, and you drop it on there, the fuel is going to go out at a faster rate than the oil. And so you're going to have this dark splotch in the center. And it becomes pretty obvious that that's what's going on. You don't necessarily have to test it, because you can actually kind of see it. The other thing that can happen is we can get in a 7.3, we can actually put fuel in our coolant, because the coolant and the fuel are separated by an O-ring. And if that O-ring deteriorates, either the O-ring deteriorates or the copper seat that it sits in deteriorates, and we get copper into the fuel. When you shut the engine down, The coolant pressure could still be up, 21 PSI in the cap or in the radiator, and that coolant can migrate itself into the fuel system, and it will circulate back, and all of a sudden you're going to have coolant sitting in the bottom of your fuel bowl, and you're like, how in the world did I get coolant in here? Well, it's because those things have failed. And what that results is when the guy starts it first in the morning, it misfires, it smokes, it does some horrible things, and then it kind of clears out. So the other thing we can have is a problem is we can actually have fuel in our engine oil. And that really becomes an issue. And the high pressure pumps, if the high pressure pumps that are, especially on the 6.4, that entire pump is underneath a cover inside the engine, and the front pump seal on that fails, and it fails and leaks and fills the crankcase. So this thing's running, and all of a sudden this guy's got, half a crankcase full of fuel. Well, all that becomes sitting in a hot engine it runs at 200 degrees inside there. Okay, what is fuel vapors? The diesel fuel starts to vaporize at maybe 120, 140 degrees. Now all of a sudden this stuff's starting to evaporate and everything, and now it's pulling in those vapors and turns it into a liquid and takes it through the crankcase ventilation system, and the engine runs away on it and melts an engine. It's a very real problem. So another thing that we can have is a problem. We talked about priming the systems. Some of the ones are hand bleeders and stuff like that. We don't have to do that anymore. We have electric pumps that we just cycle the key on and they'll bleed themselves out. We did talk about that. You can jump the relays or use the computer to turn the pumps on and just let the pumps run and purge themselves out as well. The 6.4 will, if you did stall it and you needed to hook up all that equipment, if you actually hook the computer up to it, turn the pump on and let it sit for, 20 minutes or longer, it will actually purge the air out of it and it will start. But it's just a long, involved process. Okay. Talked about all of this stuff here. Talked about that. Engines are dirt prone to. Okay, so these are some diesel fuel system cleanliness practices that you guys need to just be aware of. That diesel systems are extremely sensitive to dirt contamination. Remember, those tolerances are super tight. The smallest particles of anything can get in there, and the least they can do is wear the parts out. But dust and dirt particles can get inside your fuel system, and they can actually hold things open. When we're going to get into the common rail fuel system, that common rail fuel system moves, 40 microns a valve moves, very, very, very small. And you get any kind of debris inside there that plugs that stuff up or changes that, and it can screw the whole thing up. And if you if you get a piece of dirt in there and it keeps that injector open, remember that that fuel coming in there is at 30,000 PSI. And if we hold that injector open, it's going to just dump that fuel straight in that cylinder, and it will destroy a piston in less than a minute. It'll just melt it. So the point of this is that you keep things clean. When you take fuel lines off, you're supposed to cap them. Okay. You cap them to keep the dirt from getting into the injectors. Any fuel rails, you clean them. You use only solvents and stuff that are recommended to be used. Never place fuel components on the ground. Take them off and set them on the ground because it's dirty. You don't want them, you want to keep them. Do everything you can to keep things clean. Okay. Keep the new parts in their original packages until they're ready to be used. And it will always treat you well. Don't reuse gaskets and seals or washers. Always replace them. You're dealing with high pressures, and diesel fuel loves to leak. So make sure that you're replacing everything that needs to be replaced. I'm personally, I'm not a big glove wearer. I don't wear gloves. But I've learned to not touch the sensitive areas of parts. Not only not only protecting myself from the diesel fuel and stuff like that, but the oils in our skins and stuff on those really, on those nozzle pieces and all that stuff, they're super, super sensitive. So we want to make sure that our oils and stuff don't get in and affect them. Some people's chemistry is a lot worse on parts than others. But we just need to be really careful when we're dealing with these parts. Okay. Summary. I got a couple of summary pages here. Operating and servicing a low pressure system is probably the most critical and quick starting, engine durability, and getting reliable trouble-free operation from diesel-powered vehicles. The functions of the fuel system include storing and supplying the fuel free of contaminants and vapor, and a correct pressure to the high pressure injection system, removing water contamination, preventing fuel wax from gelling, and regulating fuel temperatures. Okay. While the most obvious function of the fuel tank is to store the adequate supply of fuel for the engine's application, the secondary function is to allow fuel return from the engine to cool after absorbing heat from the engine and the fuel injectors. Fuel pressure transfer, low pressure fuel transfer lines connect the critical circuits to the low pressure system. Fuel tank pickups can be integrated in the fuel pump sender or just a regular sender itself. These modules may include several components that may or may not be sold separately or serviced separately. Most of the time they are not. If it's a pickup or if it's something in the tank, it's one big item. Sometimes the sender units come off them, but usually not. Fuel filters remove dirt contamination from fuel that could abrasively wear fuel injection components. The fuel common components found in today's fuels are asphaltene, air, water, microorganisms, and wax. Although the wax is not necessarily a contaminant unless it's cold. To prepare fuel for cold weather use and avoid operating difficulties, the low pressure system is often equipped with a variety of devices to condition the fuel by removing water and dissolving wax. Fuel transfer pumps are used to move fuel from the fuel tanks to the high pressure fuel system. The fuel must be supplied with adequate volume at the correct pressure for every operating condition. And that's really a key thing, that we really need to make sure we got the fuel there to do that. The variety of pumps exist to match the unique requirements for each high pressure fuel system. The operation of the low pressure supply system will need to be evaluated when investigating complaints regarding low power, hard or prolonged starting, rough engine operation, failures in high pressure injection components, whether fuel filters are replaced, or if an engine has run out of fuel, the system usually needs to have the air purged in order to get it to start. And unless otherwise indicated, all photographs and illustrations are the copyright of Jones and Barrett Learning, which you really don't care about, do you? Okay. Does anybody have any questions about low pressure fuel systems? How are we doing time-wise? Oh my gosh, it's 7:30. Gosh. Is anybody gonna go to the bathroom? Are you guys okay? This other PowerPoint's not too long. Is this right? Oh, hang on. Where'd you go? Hang on. Bear with me. I lost it. I lost you guys. Where's my Zoom? Oh, that's the wrong one. Bear with me. Oh, there it is. I found it. Oh yeah, I got you guys low and I can't see it. There we go. Okay. Okay, high pressure fuel systems. So we have, I've already talked about this. We have a high and a low pressure fuel system. I'm only want to hit some highlights in this PowerPoint because I want you to understand how the high pressure systems work. And then when we get into the Huey system and the common rail, we'll get into that. There's a bunch of different types that are out there, old distributor types that would have been the old 6.9s and stuff like that. Not even going to talk about how they used to work, but then you got the common rail systems. That's what we're using most of today. You have your Huey systems, and then your another kind of system with a unit injector. Their purpose of the high pressure system is to supply the fuel to the combustion chamber. Okay. The efficient diesel engine's operation relies on precise quantity of fuel being delivered or injected at high pressure at the right time in the combustion chamber. Okay. And we have to use high pressure because remember, we got high pressures, high air pressures inside that, the combustion pressures inside there. And we got to be able to get our fuel into that air. And so that's the purpose of a high pressure system. So at the end of the day, all high pressure fuel systems need to be able to deliver high pressure fuel. How they do that is going to be a variety of different ways. In the old times, they used a regular camshaft that would run a piston. And if you look at this diagram, and this is important for you to understand, fuel is going to come in where the in port is right here. Okay. As this piston moves up and down, as that piston's moving up, the fuel, your transfer pump pressure is going to be filling this chamber with fuel. But as soon as this piston moves past this port right here and shuts this port off, that's when injection begins. Now you're going to be building pressure inside here and pushing this fuel out. Okay. How a nozzle works, which this is a basic picture of a nozzle, is this fuel pressure comes down here, works along the bottom of this thing here, and this pressure that's inside here pushes up against this, like this little ring here and here, and it pushes this up off its seat against this spring pressure, and then the fuel that's in here sprays out. As this fuel pressure drops, spring pressure overcomes this, and this needle seats back down in here and seats it. Okay. No matter whether it's a 1920 Bosch design, a Huey injection system, a common rail system, anybody else's system, every single diesel engine uses some variation of this type of nozzle. Okay. So I want you guys to understand how this nozzle works. And I do have a pretty good explanation for it and even a different picture in your Canvas so that you can know how that operates. Because this is critical to understand. And the reason I'm even going through this PowerPoint is just so you guys can understand how that works. Okay. Now, how this high pressure fuel is pumped these days is quite differently. We're going to do it different with a Huey injector. We're going to use high pressure oil to do that. And I'm going to yap at you at length on Thursday about it. And then on a common rail system, we're going to do it yet a different way, but really kind of the same way, but it's just how we're controlling it is different. So that is how it works. And so you need to have an understanding of that. If you have an understanding of that, then you will really be able to move along in the diesel world quite well. Okay. The fuel needs to be delivered highly pressurized for several reasons. It must have sufficient pressure to penetrate the dense combustion chamber gas, the mass that it's in there. It must be able to atomize the fuel, distribute it at the right time. It has to be mixed with the air to absorb the heat. Remember, that fuel has to be able to atomize so that it can vaporize and that it can absorb the heat so that it can vaporize, so that it can burn and get the compression right when it needs to happen, right at the right timing. Okay. As an engine speed increases, the time in which all that takes place has to happen a lot quicker. I mean, just think about if that engine's turning 2000 RPM, how much time does it have to actually inject the fuel, look what it has to do. It has to atomize the fuel, distribute it through the combustion chamber, let it absorb the heat, be able to vaporize, and then burn. All that has to happen in probably 10 times faster than a blink of an eye. It's just super, super fast. Okay. So it's really, really important. Where'd I go? High pressurization, called atomization, produces the increased small droplets. Remember, if we put it in, if this thing doesn't atomize the fuel properly and puts it in big droplets, those big droplets are delayed in burning, and that's what's going to cause. Remember, Crystal, you were asking what causes that banging noise in an engine, that cracking noise. Well, that's what if the fuel goes in there in too big a droplet, it delays the burn, and then all of a sudden you get this uncontrolled burn, and that's what gets that crack. And one of the things that helps us in the new modern engine is how we can atomize that fuel better and stop that from happening. Just again, how those final smaller particles are going to help us solve all the problems of fuel NOx and particulates in the exhaust and all the emissions. So high pressure system is responsible for the following tasks: metering the proper amount of fuel, the timing, controlling the rate of delivery. We'll talk about that. We talked a little bit about the atomization of the fuel and then distributing it well through the combustion chamber. So metering is the process of how much fuel is going to be in the cylinder. Remember that this engine isn't controlled by a throttle. It's controlled by how fast, how much power or torque is being produced out of that cylinder. So we put a little bit of fuel, we're only going to get a little bit of torque out of that cylinder. We put a lot of fuel in there, we're going to get a lot of torque out of it. And the engine speed is going to be controlled by how we're resisting that crankshaft. If we're sitting there at a stop and it's only going to be able to turn so fast, but if we're driving down the road and we don't have anything stopping that crankshaft, the more fuel we put in, the faster it's going to go. And we're using fuel metering to control engine speed and torque. Okay. Just talked about that. So less fuel, less torque, more fuel, more torque. We just talked about that. We just talked about that. Okay, so engine timing. Engine timing is important, and the high pressure fuel system is 100% responsible for fuel timing, whether it's a mechanical type fuel system or it's computer controlled. All of the timing is critical to how this engine runs. The faster the engine runs, we have to advance the timing, because as that fuel is delivered, we have less time for it to actually do all those things. So we have to we inject it a little bit sooner so that it has time to atomize, absorb the heat, vaporize, and then distribute through the cylinder, all those things. So not only the amount of fuel that's going in, but the timing of it. If it's I think in here we're going to talk about cold engines. Okay. If it's a cold engine and we start putting the fuel in too late, it's going to take it more time to burn, and not all of it's going to burn. It's going to run out the tailpipe. So timing is super critical about how much fuel we're getting in there and what time it's getting in there, so that it has adequate time to do all the things that it needs to do and burn. Okay. So the high pressure fuel systems 100% in charge of injection timing. If we get cold timing is really critical for emissions, and they're really critical. The emission laws are really critical about that, so that we're not putting all that white smoke out the tailpipe. If you get to an old diesel, if you look at an old 6 liter or something like that, especially on a cold morning someplace, man, they white smoke and they're smoking and doing all kinds of stuff. It's because their timing's late and they're not burning the fuel the way it's supposed to. So in modern engines, we're doing everything we can to make sure that's all happening when it needs to. The other thing that's going to happen with timing is when the engine's cold and when we're cranking it, we're going to retard the timing first, because we don't want to inject that fuel on that piston too early and cool the combustion chamber down. Remember, when this thing's cranking and it's a cold morning, we're trying to get heat in this thing to be able to start that engine up. So we're going to retard the timing so that it's going to happen at top dead center, or maybe behind after top dead center, so that we get the ultimate compression heat we can, and then inject the fuel. But as soon as it starts, we're going to start advancing that timing so that we can make sure we're burning that fuel that we need to. We talked about that. This is just talking about the fact that they're messing with timing and stuff to be able to make sure that we're stopping knocks and stuff like that. But this is where it's just something I really want to talk about, is pilot injection. And pilot injection, we're going to get into it at length with the 7.3 or with the HUE injection system. And then it really gets crazy in the common rail. But pilot injection, known as split shot, it's a concept in which as we fire the injectors off, what we're trying to do is we're coming up on top dead center. If we just drop a big old slug of fuel in there, one of the reasons that we get that common diesel knock noise is because we got so much fuel in there that the fuel particles can't atomize. They can't get enough heat to warm up enough, and they don't get hot, and they don't start burning properly. And then all of a sudden, boom, they go off. And so you get that diesel knocking noise. So what we do with pilot injection is we're going to squirt a little fuel in there in the beginning, probably, I think they say 8 to 10 degrees before the main injection event. So we're going to get a little fuel in there, and that little bit of fuel is going to go in there, and it's going to start a fire. It's going to flame propagation across the top of that piston. And now you've got a hot combustion chamber, and then we're going to dump the slug of fuel in there. And what's going to happen is now that fuel is already, that combustion chamber is already hot. We've got flame already happening where you introduce that fuel in there, and then you get a way more efficient burn that's going to help eliminate noise, going to help emission out the tailpipe immensely, and all kinds of good things are going to happen because of it. So we call it pilot injection or split shot injection. And I think I've got a slide in here. Now the early ones only did one injection event. Some of the later ones had 2 injection events before the main event. But the common rail systems in the 6.7 can have as many as 10 injection events every time that cylinder fires. So that's all happening super, super fast. So this is what you would see if you watched it on a graph. You would see, if it was a one pilot injection, you'd see one little shot and then the main, or you could have 2. And then you can also have post-combustion events. Okay, so you can have them after the fact. And the reason they're going to have post-combustion events is because after that cylinder fires, a lot of times you're going to have soot and stuff build up inside that cylinder. So we can actually, after that cylinder fires, push a little bit more fuel into that cylinder, and that helps burn out the rest of that. So we burn the soot and have a lot cleaner stuff going out the exhaust. The other thing we can use post-injection for, and we'll talk about it in a few weeks with exhaust filters, but modern diesel engines have exhaust filters on them, and we have to clean the exhaust filters out. We use heat to do that. So we'll push exhaust, we'll have a post combustion event where we'll turn the injector on during the exhaust stroke and push heated fuel out into the exhaust, and that hot fuel goes out there and it will help cook off the DPF. And we're going to explain that in a few weeks ad nauseum, and you'll understand it. And so that would be a post-combustion, it's getting late, post-combustion event. So we have pilot injection, which is a pre-combustion event. Then we have our combustion event, and we can have post-combustion events. We've already talked about this, that we need the high pressure We need to have the high pressures so that we can penetrate the mass airs, the dense mass air in the combustion chamber. And yeah, we've talked about this. Talked about that. Talking about fuel pressurization, we talked about that. Just as this thing passes this valve, all your fuel pressure happens. We've talked about that. This is just a picture of a typical high pressure fuel system where the fuel supply is going to come into the high pressure pump, and then the high pressure pump is going to deliver high pressure fuel to these injectors, and then they will have return fuel back. I mean, just not any big deal there. We will cover those at length. Fuel atomization is very important to us because we want to get that fuel. We want to get those fuel particles as small as we can so that they can absorb the heat quickly, so that they can vaporize and then mix with the air. So that is an important thing. That is a test question. What are we trying to do? Is we're trying to get that fuel to atomize. We're not trying to get it to vaporize. We're trying to get it to atomize so that it can collect the heat, absorb the heat, so that it can vaporize. Okay, and it'll mix with the air, and then it can combust. If the thing's dirty and gross and not working well, it doesn't atomize well. We get big particles, big droplets, and we're looking for little droplets. Remember that efficient combustion requires exceedingly fine particles of fuel. So finer atomization fuel ignites sooner, burns faster, and burns more completely, and it's quieter. Remember, if big chunks of fuel going through there, big droplets, they make noise. Summary, let's make sure we covered everything here. These fuel systems have two main divisions: low pressure transfer system, which stores and supplies fuel for the injection system, the high pressure system, which delivers fuel to the combustion chambers. Efficient diesel engines operation relies on injecting a precise quantity of fuel injected at high pressure at the correct time in the combustion chamber. Okay, that's good to know. High pressure injection systems operation is better understood by examining the functions common to all injection systems. That's what I'm trying to do with this is just saying these are the principles that are involved with the high pressure system. How we're going to do that's going to be different when we get in those other systems. Ensuring that fuel is highly pressurized is necessary for several reasons. We must have sufficient pressure to penetrate the dense combustion chamber and the air mass at high rotational speeds. Only a short amount of time is available to inject the fuel, and high pressure is necessary to break that liquid fuel into a fine mist. So if we don't have that high pressure, we won't get it into a mist. All high pressure injection systems perform the following tasks. They meter the fuel to the correct quantity. They time the injection of the fuel. They control the rate of the fuel delivery, and they atomize the fuel. Okay, and then they pressurize and distribute the fuel throughout the combustion chamber. Those are the main things that we're trying to accomplish with a high pressure system. Diesel engines meter only fuel so that they can control the engine speed and torque. Remember, we don't have a throttle. We don't meter air. We're only metering the fuel. Metering is a process of measuring and delivering the correct quantity of fuel delivered to each cylinder for various speeds and loads conditions of the engine. And in today's engines, we do that super precisely so that we have a cleaner engine than any gas engine out there. To vary vehicle speed and power output, pressure in the cylinders must increase or decrease by changing the amount of fuel injected to burn. Increasing combustion pressure inside the cylinders increases the torque output. Decreasing the combustion chamber decreases the torque output. That's how we change the speed of the engine. More fuel, faster. Less fuel, slower. For efficient combustion, clean emissions, and good engine performance, precisely timed injection events are crucial. Efficient fuel systems must have the capability to change the point when fuel is injected based on a variety of engine operating conditions and control algorithms. Factors that influence injection timing include pre-ignition temperatures in the cylinder, fuel droplet size, combustion chamber turbulence, fuel quality, and more. Okay. Cold cylinder components and low ambient temperatures create exceptional operating conditions that require adjustments to timing. So remember that a cranking engine, we want to have the timing retarded, but when it's running, cold, we want to advance the timing. Diesel engine emissions characteristics are significantly affected by changes to ignition timing. For example, slightly advancing the start of injection may reduce smoke, increase power, and reduce fuel consumption, but typically result in higher NOx emissions. Okay, so they're doing a gigantic balancing act, trying to get the timing perfect so we get the right power with the least amount of emissions. And unless otherwise indicated, all photographs and illustrations are copyrighted of Jones and Barrett Learning, which you don't care about. Does anybody have any questions? Did I go too fast on that? I will post this PowerPoint and the other PowerPoint in the Canvas. But the Canvas also has some really good reading on all of this so that you are get a full understanding. If I blew through it too fast, if I did blow through it too fast, you can ask me any questions that you would like because we have 2 minutes. And then if you have the book, you can read too. But I think I got out to you in the high pressure system what I wanted you to know. I wanted you to know how a nozzle works, because that's important, and the fact that somehow we are creating high pressure. And we'll talk about how we create that high pressure on the Huey system on Thursday. And that's a really fun injection system. It's very unique and a lot of fun. So anybody have any questions? Crystal, what are you eating?
Broccoli.
Oh, I'm sorry. All right. Do you guys have any questions? Arturo and Gavin, you good? I put him to sleep. Are you guys there?
Yeah, we're good. I'm good.
So you guys didn't make it on Thursday. Are you going to be there this Thursday?
Yeah, I'll be here this Thursday.
Okay.
Yeah.
All right. Because this Thursday is going to be really, really important. It's you really want to sit through that. So, okay. Long night. We'll Thursday will potentially be long, but then next week should go a lot quicker. The common rails a lot less to talk about. Okay. Have a good night.
Thank you.
Right.
Thank you. Have a good night.
Right.
Thank you. Have a good one.